All right, today we're going to talk about the Cartesian equation of the parabola when you think of a parabola as a conic section. So a parabola has a vertex, which you're familiar with, h comma k, and it can be dilated by a factor a, which is often called the amplitude. And that's also going to tell you if it's going to be opening left or right or up or down, depending on what type of a parabola you're working with. So if your parabola starts with y equals, or it's the y that isn't squared, that means it's going to be opening up or down. And to figure out if it's up or down, you need to look at the value of a. A positive a will be opening up, and a negative a will be opening down. If your parabola starts with x equals, and x is not squared, that means it's going to be opening in the x direction. And remember that this type of a parabola is not a function. And so the a here, if a is positive, then it's going to be opening to the right. And if a is negative, then it'd be opening to the left. So that's the general idea behind the parabola. So now we're going to do this example here. We have the graph of a parabola, and we need to come up with the equation, and then we're going to plot it on the graphing calculator and confirm that it actually is the appropriate graph. So the first thing we need to do is find out what the vertex is, and you can see the vertex right here. I know the numbers are small, but if you look down here on the x-axis, this is 5 and this is 2. So the coordinates of the vertex are 5, 2. So to come up with the equation, now that I know the vertex is at 5, 2, I just need to figure out the amplitude. Now this is a sideways parabola, so this is going to be opening in the x direction, which means that it's going to be an x equals parabola. And I'm going to have my 5 here. I'm going to have some a value. I don't know what that is yet. I'm going to leave a space there. And then y minus 2 squared. That is the k value from my point. So to figure out what a is, I just need to choose any point on the graph that I can clearly see. So I'm going to choose this one right here at 3, 0. And I'm going to put the x value in for x, the y value in for y, and I'm going to solve for a. So when I put 3 in for x, I have 3 equals 5 plus a times y is 0, 0 minus 2 squared. 0 minus 2 is negative 2. I'm also going to bring this 5 over to the other side, so I have negative 2 equals a times negative 2 squared. Negative 2 squared is 4, so I have negative 2 equals 4a. Therefore, a equals negative 1/2. So that gives me the equation that I have x equals 5 minus 1/2 times the quantity y minus 2 squared. So that's part A. That's the Cartesian equation for my parabola. Now if I want to go plot that on my graphing calculator, I have to get it to say y equals, which is quite a bit more work. I'm going to do that on another page. But this is the equation in graphable form. So now to confirm that the graph is correct, I'm going to start with the equation x equals 5 minus 1/2 y minus 2 squared. And now I am going to try and get y by itself. So I'm going to bring the 5 over to the other side. So I have x minus 5 equals negative 1/2 y minus 2 squared. I'm going to multiply both sides by a negative 2. That will get rid of the negative 1/2 here. So now I have y minus 2 squared equals negative 2 times the quantity x minus 5. And then to get rid of the square, I will take the square root on both sides. So I have y minus 2 equals plus or minus the square root of negative 2 times the quantity x minus 5. So then the last thing I have to do is get y by itself, so I have to add 2 to both sides. So I have 2 plus the square root of negative 2 times x minus 5. And I have 2 minus the square root of negative 2 times x minus 5. I can put one of them into y1 and the other one into y2. And when I look at the graph, it should look just like the graph on your notes packet. So confirm that, and that is how we isolate y in a situation like this.